Okay, for today it's a review for the circle trig test. If you knew nothing else, you should know where things like pi over 6 are, etc. So let's just first have you find a few places. Would you, and then check with your partner, find where pi over 6 and 5 pi over 6 and 11 pi over 6 are on this circle. Draw in those three spots. They form angles, of course, but we think of them as a spot around this circle. Draw them, label them, check with the kid next to you. I'm going to pause for a second. So by now, hopefully you have easily figured out that that was about 30 degrees and thus pi over 6. Think of pi as 180, and then 180 divided by 6 is like 30. So that's supposed to be like a 30-degree angle. And then 5 pi over 6 is like not quite to 180. Okay, and then one more 11 pi over 6, that's just south, so to speak, of 2 pi, also known as 12 pi over 6. So that's this last one's right here. So this is 11 pi over 6. This one's 5 pi over 6. And this one's just pi over 6. All right, now let's just take this one. And would you please tell me 3 names of angles that are coterminal to that, as in they terminate in the same spot. 3 coterminal angles to that. So 3 angles, you could actually, I could ask you for 7, but let's just go with 3, that are the same as 5 pi over 6. One is negative 7 pi over 6. Raise your hand if you remembered the negative way that you could go. Good. Next is you could call it something else. Instead of 5 pi over 6, we could call it a bunch of pi over 6s, 5 pi over 6s, as in pi over 6 is 30 and 5 times 30 is 150. 5 pi over 6s means 5 30s, which would be 150 degrees. That's 2 ways to do it. What's another way? You go all the way around as 360, and then you go another 150. How many of you thought of that way? 360 plus 150 for, is it 510, I think? Okay. All right, and then one other negative one, I could say negative in degrees. And this would be negative 180 plus another 30. 180 plus 30, negative 210, I think, right? Anybody have negative 210 degrees? Okay. And could you also go negative 360 and add another 210? Yes, you could. So there's a lot of combinations, but that's the concept of coterminal. All right, next one. Imagine for a moment, instead of just making it super easy and saying, if this is 10, and this is 10, and this is 30 degrees, how long is this? That should be a no-brainer easy, because you should know a formula for that. I'm going to make it a little harder. We're going to go around the outside this way. It's the same concept, but just obviously makes it a little more challenging. If this was a pre-calc test, it is. You might have variables, but just right now, just handle it this way. Find how long that squiggly line is. Then, as a bonus add-on, find the area of the shaded region, which is basically everything except that one little wedge. So find the arc length and the area of that really big sector. Pausing for a second, let me try that. Okay. Here's the 2 formulas in case you aren't using one of the right formulas. And theta over, well, I'm using degrees right now, so I'm going to say 360. Do you get if I was doing radians? I'd do theta over 2 pi. Okay. And then times pi r squared. So this is the area formula. This is the arc length formula. Know them both. We don't give you these formulas on the test. Oh, thought you had a question. Okay, raise your hand if your group is done. You have both. All right, and that's definitely the majority. So pi over 6 times 10 is 10 pi over 6. You should simplify that, 5 pi over 3. Oh, wait a minute. I just found the little short arc, didn't I? Yes, I did. I just found this guy. Oops. Okay. So then, that wasn't the right angle. That was the right angle to find the little short arc, but the actual right angle, the correct angle I should be using, would be instead of 12 pi over 6, which would be all the way around, I would use 11 pi over 6. And so it's 11 pi over 6 times 10, which would be 110 pi over 6. And yes, that can simplify further, but let's not make it any more complicated for now. Raise your hand if you had that one right. Okay. That was for the arc length. That's the green squiggly line around the outside. All right, next. This one, since I have it in degrees, I'm going to use 30 over 360, which can simplify to 3 over 36, which can simplify to 1/12 of pi r squared, and r is 10, so it would be 100 pi, and it's 1/12 of that. So 100 pi divided by 12. Can anybody verify that one? Okay, rats. I just found the small area again. I really wanted to do this one, but I knew it'd be better for you if I did a different one. So I keep on finding the answer to the small thing. All right, so then what's the correct angle now? 330 out of 360. So it'd be 330 out of 360. I'm going to arrow down here. That's most of the circle, right? Times pi r squared, and our r is 10. So that will be 100 pi times 330 over 360. I'm going to do some canceling and make this into 100. And so then it's going to be 3,300 pi over 36. Now, any questions on that one? Yes. Yes, you should always simplify. Nobody has ever been marked wrong for you simplified. But you have, in the past, lost 5% for not simplifying. Now, it depends on how hard the test is, whether or not I would be super strict on simplifying or not. But the safest answer is simplify it. Okay. Next, we'll get into a different type of question, which has to do with rotational motion. Question first. Yep. You're right. It absolutely reduces. I mentioned that, but I said, yes, I suggested that you should always reduce, but I didn't want to take the time right now. So I probably should have just done it so I wouldn't be talking about it right now. Yes, you should simplify that. Okay. Now, next one is about rotational motion. Imagine for a minute this is a wheel of a little car. Okay? And this car is going pretty fast. You take a video of it, and you notice that you like mark one little edge of it, and you can see how often it turns around, and it goes around 3 times per second. You can tell that the wheel is going around 3 times per second. 3 rotations per second. Now, I haven't told you how big that wheel was. Do you get how that does matter? Because one rotation, if it's a really big wheel, that might be like a meter. Well, one rotation on this would be, of course, 1 circumference. And I wouldn't be so nice as just saying what the circumference is. But I'll tell you the radius is 3 inches. The radius of my little wheel is 3 inches. And it goes around 3 rotations per second. Figure out how fast it's going in miles per hour. So if I had a little piece of gum stuck to the tire, how fast is the little piece of gum going? And I know it's 3 rotations per second, but I want you to change the units to miles per hour. You're going to be multiplying by a whole bunch of factors. Now, on this question, since there's no calculator on the test, you would not have to multiply it all out. You just have to tell me what should you multiply. So I'd need to really see your work. because I'm going to be looking through finding all the little conversion factors you multiplied by. Now, I know some people are going to get rid of rotations and right away replace them with a circumference, and that's not a bad idea. One rotation is a circumference. But I'd rather see it like this. One rotation, so that rotations can just cancel each other, right? What is one rotation? Well, it's one circumference. Well, how big is a circumference? Anybody know the formula for it? Because if you didn't know a formula right there, you'd be toast. Circumference is 2 pi r. Circumference is pi times diameter. Who is right? They're both right. It's the same formula. Just one's got an r and one's got a d. Go ahead and use that. Get your final answer, which I don't want you to multiply out. I'm not going to be multiplying them out on the test. I'm just going to be looking at your work and seeing if you multiply by all the right little factors. Pause for a second while you finish that one off. One circumference is 2 pi r, and that's in inches. It's always important to keep the units straight, right? So one rotation is 6 pi inches. Now I get some people just wrote 6 pi inches right here. I can live with that, but I like it better if you write it out like this and make the rotations cancel. Okay, now I got to get inches out of there. So I put inches on the bottom. And some of you are going to be smart and right away change your inches into something like really big, into miles. But some of you guys are going to go, I'm going to take it one step at a time. 12 inches is 1 foot, and that's totally okay. I don't think that that's dumb. That's just being careful. I know that's true. And then I'm going to change my feet to miles, but you better memorize this one, 5280. If you do not know it, you will get it wrong. So there's usually one kid who's like, I don't remember, can you tell me? And I have to say, I know, I warned you. You have to know that one. Okay, and that's 1 mile. That way the feet cancel. And now I have miles per second. Swing and a miss. So what should I have? Well, I got to have it some factor that gets rid of seconds. SS, can you tell me what to do? And there'll be some people that are going to go direct. What do you think you could do to go direct from seconds to hours? 3,600 in 1 hour. What you said was not wrong. It was totally right. But I'm out of board space, so I'm going to stop right there by making that 3,600. Okay, and now I cancel stuff. Seconds cancel, and now that's messy, but that's what I'd be looking for on the test. I don't need you to multiply it all out. Okay, I just need to see their factors. So I'm going to go through and look for, again, this isn't the problem on the test, but there's going to be something like it. And I'd be looking for, do they have the 12 and the 5280 on the bottom? And do they have the 3 and the 2 pi times 3 on the top? And I'll make sure the units are there too, like inches or miles per hour or whatever. In this case, miles is there and hours is there, so that they would have passed. All right, that's a lot of topics, but there's more. Next one, it starts to get a little deeper. These are like R3 territory. Some of those previous could have been maybe, like easy R3s. All right, if I say that I wanted the secant of 5 pi over 4, I hope you would go, well, I don't know how to do that, but I do know how to do the sister function, so I'll do that. Try to remember which ones go with which ones and figure out secant of 5 pi over 4. Okay. Here's where 5 pi over 4 is. It's down there. Here's where 4 pi over 4 is. You know why I know? Because it has to simplify to just pi. And so this must be where 5 pi over 4 is. And then this is my triangle. And this is a 45 because that's the same as what pi over 4 is. And then this is a 1 root 2. And then all it takes is one of those things to be wrong. What's wrong? That's negative and that's negative. I forgot the negatives. So easy to do. Okay, then secant. Wait, I don't want to do secant. I'm going to reject this reality and substitute my own. What is the secant? Well, it's the same thing as the, which one? Do you know? Cosine. Cosine of 5 pi over 4. Is it exactly the same? No. But when I find the cosine, I'll be really close, and then I'll just have to do what? Flip it over. Okay, reciprocal. So cosine of this spot is adjacent over hypotenuse, and that's -1 over the square root of 2. So this is true. And now if I do the if I flip, think of it as an inverse of both sides, I'll end up with the secant, which is flip this. And where does the negative go? It doesn't matter. You can put it on the top or the middle or the bottom. And of course, this is one thing that's important. There's no such thing as flipping an angle over. Okay, so that angle stays the same. All right, final answer, -√2. Or what I wrote, √2 over 1, and it's negative. Raise your hand if you had that one right. Okay, so do you get that there are 6 functions like that? All right, so then I'm going to give you one where if I said sine of some angle was -1/7 in quadrant 3, then what is the cotangent of the angle? Hint, first figure out where it is, draw the picture, label the sides, then don't figure out cotangent, figure out tangent. I'm going to pause for a sec. Okay. This is I'm going to draw a triangle, and it is not going to be perfect, but I'm going to try to make it the opposite side's kind of small and the hypotenuse side's kind of big, relatively speaking. Okay, because this is not one of our normal triangles. So the hypotenuse is the big side. I think I got this right. All right, so then the last side would be square root of, I have 49 and I have 1, and then do I add them or subtract them? Subtract. So square root of 48. Now, does 4 go into 48? Yes, it does. Does 16 go into 48? Yes, it does. How many times does 16 go in there? 3 times. So then this is √16 and √3, which is 4 √3. Yes, you can be docked for not simplifying. Depending on how hard the problem is, it won't just be for you. I'll have to decide for the whole class whether they're going to lose 5% is the minimum for not simplifying. So try to simplify if you can. Okay, so then it's also negative because it's going to the left. And now I'm going to figure out the tangent first, and then I'll just flip it. So tangent, TOA, opposite over adjacent, -1 over -4 √3. Negatives cancel. And then I'm going to flip it, so I'm not going to take too much time before I do the reciprocal thing. And I now have cotangent of this angle is +4 √3. Raise your hand if your group had it right. Nice. That's a tough question, and you figured it out. Okay. Next is about angles. Be careful on this one. I need all the answers that are between 0 and 2 pi. I want angles that are between 0 and 2 pi. But notice, it wasn't a typo. I chose not to include 2 pi. Why would you not give an answer of 2 pi as one of your answers? The same exact thing as 0. And 0 would be simpler, and you don't want to list it twice. So, okay. So then, sine, no, so we're doing sine too much. Let's go to cosine. Cosine of some angle is -1/2. Now, I did not give you any restriction like it is in quadrant 2, or it's in quadrant 3. So there could be 2 answers. I'll pause for a second while you give this one a try. Okay, just make sure you're not too far off here. All students, take calc. There's 2 places where cosine's positive. Can't be there, can't be there. And those 2 quadrants, raise your hand if you were in the right 2 quadrants. Okay, good. Then, I'll stop there for a second because I get the feeling some groups aren't done. Okay. Cosine, adjacent, hypotenuse. Must be square root of 3 over there. It'd be really smart for you to memorize what's across from what. What's across from the 1 is a 30. What's across from the √3? That's the bigger one, 60. So that's how your 30 and your 60 go. Don't just assume because of how you drew it. You got to go by where the numbers are. So that's a 60-degree angle. If that's a 60, that's the same as a pi over 3. And then that's a bunch of pi over 3's. 2 pi over 3 is your first answer. If you got that one right, you'll probably get the other one right. Raise your hand if you had 2 pi over 3. Okay, good. All right, I know some of you thought that was a 60 and therefore thought it was 5 pi over 6's. You're wrong. That's the most common mistake to answer. Okay? It's because of what it's across from. The 30 goes across from the 1. The 60 goes across from the root 3. Okay, and then if this is 2 pi over 3's, this would make it 3 pi over 3, which simplifies to 1 pi, right? And then the other one would be down here, which would be 4 pi over 3. I don't require you to draw that second triangle even because it's, you know where it's got to be. You don't need all of its sides and angles. That's just kind of wasting time. Okay, 2 pi over 3 and 4 pi over 3. All right. Whew, we're almost done. It's a good thing because we're almost out of time. This is the part where, just like I did last hour, I'm going to tell you before I do this last problem with you, what I would do if I were you tonight. I don't feel like this is an incredibly hard test. I try to be honest with you on each test, okay? But that also means this is a great chance to get an A. So for some of you, you still might want to study for a few minutes so that you can lock down an A because your last test wasn't that great. This would be a dumb time to go, oh, it's a pretty easy test, so I just won't study, and then you get a B on the easy test. That'd be sad. Okay, so study. How would I study? You can always do the same things as before. Whatever problems I've done with you in class are obviously important. Then you could look at problems we skipped on the homework and do those for practice. But there's also, if you look in the folder that's under today's date, it says review on it, there's like a million practice tests and keys and stuff. You're going to be tempted to go do problems that you're good at because they're more fun. But you shouldn't. You should try find ones that are hard for you and practice those. Because the easy ones, even though you'll get them right, is not what you need to practice. Okay? All right, so that's my advice on what you should do. I am not going to require this time that you Dropbox any proof that you do anything. But I do strongly encourage studying because this could be an easy A for many people, and you don't want to miss that chance. All right. So let's see. Pausing for a second. All right, so for this one, I'd like you to say if the sine of 5 pi over 3 is, well, first of all, you should be able to figure out what that is. No, that's not how we do it. Sorry. I'm going to do sine of the angle is, let's make up one that's typical. Negative root 3 over 2. There. Then, if I give you this hint, I'm telling you what quadrant it's in. Tangent of the angle is less than 0. Then, what's cosine of the angle? All right, I'm going to pause for a second. Will you figure out that answer? Notice I did not ask for the angle this time. This time I asked for cosine of the angle. So here's your answer on this last one. Stay quiet, please. It had to be in this quadrant because tangent had to be negative. Shh. I don't mind you getting up, but I do mind if you move desks or are loud. Just be quiet for a second. All right. Sine is opposite. Hypotenuse. That one is the key angle, and I want cosine of that angle is adjacent over hypotenuse. Should be 1/2. Raise your hand if you had 1/2. Okay, good. Have a great day. Make sure you study.